Hey everybody, this is Larry. This is day 24th of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join my Discord. Let me know what you think about today's forum. No intro today, I was traveling too much. Right now I'm still in Japan, but in the island of Okinawa. So yeah, I'll show you more in the future, but today let's just get through the problems. No problem. Day 24. Hope everyone's doing okay. The weather here is much better than mainland Japan, so I don't know. Today's problem is 1561 maximum number of coins you can get. So there are three end powers of various coins, various sizes. You have to take the powers coin. In each step, you have to take any three piles, not necessarily consecutive, of your choice. Alice will pick the pile with the maximum number of coins. You'll pick the next pile with the max points, and then Bob just gets leftovers. Okay. Um, hmm. So I guess this is one of those problems that you have to try to figure out the strategy for, right? And given 10 is equal to fifth, n is equal to 10 to the fifth, what can we do? Well, I mean, every turn. So the order doesn't matter, right? Or at least the order that they give it to you doesn't matter, and you'll choose the second biggest number of the pile, the middle pile of the three. So then, how would you do it? Well, I think the quote unquote the intuitive strategy to come to me is, all right, because you have to give Alice the biggest pile no matter what. So let's say you have two different or six piles, right? It's kind of like the exchange argument, right? But let's say you have A, B, C, D, E, F, G, and let's just say that it's sorted in this order, right? Where A is the biggest, and so forth, right? And here, then in this case, I think you, well, you want the first pile to at least be A, B, and A, B, and something else, right? And in a greedy way, you want Bob to have F just because why not? Why not? Right? Like it makes very intuitive sense that if you choose E, you may get stuck with. And I mean, I guess in this case you actually wouldn't, but let's say you choose D then, right? Then well, D you could actually end up with D, but if you give it to Bob, then it's a waste. So you always want to greedily in a greedy kind of way. Always give Bob F. And then the question is, can you do better than B? Well, probably not, because if you just say, let's say you do A, C, and F, that means that no matter what, Alice, will always get B because that will be the next highest, right? So I think that's pretty much the strategy. Is just choose the two highest and then the smallest, and that's pretty much it. We could do a sort, right? That I could have. So we have to return the coins I have. So that means that the smallest is in the front. So I'll put this actually in a queue because I'm too lazy to kind of keep track of indexes. Okay, fine. Let's just keep track of indexes. I feel like I've been lazy a lot. Though they're both the same complexity anyway, so I don't know. I don't know how to type. Right, so then now, for maybe I'll use it write a while loop, right? So here while I is less than n, and then we increment by 2, or I is less than j, where j is equal to n minus 1, right? And we always have multiple of 3, I assume, otherwise this I don't know, it just gets wonky. So then now we get and obviously you can actually cut out with some of this stuff as well, but yeah, but that's pretty much it, I think. And then total, this is just the greedy. Basically you just keep on getting, oh wait, I did it in the wrong order, because okay, but I just reversed this order. This is a little bit confusing. That's what, well, for me anyway. I don't think it's that confusing, to be honest, but it's confusing for me because I'm an idiot. All right, there you go. So yeah, I think exchange, like I think a question that I anticipate. I mean, obviously you could rewrite this in a cleaner way. You could go up, like you don't need the j. You just need this only needs to go up to 2/3 of n or something like this. Give or take -1, and then you just skip every second one, right? So you could do minor optimizations. I'm not worried about it. If you want to do it, you can do it at home, and or outside, wherever you want to do it with your computer. It's up to you. So the question I anticipate getting is about the proofs, right? And why does greedy work? This is obviously greedy, but why does it work? I think, a tight proof is always, for me, I'm not good at it anyway, so I'm not going to give you a tight mathematical proof. But what we did before with the exchange argument very often, maybe even all the time, I don't know if maybe there's some DP times, but exchange argument means that, I do find a lamp, so maybe I could light my face in the future. But yeah, with this exchange argument of like what I showed you of the 6 numbers, it will lead to greedy because in every step, because that's the loop invariant, right? Meaning you do it for one exchange and then you can't remove 3 elements. And then now, like you're doing for an array of size n, now you have an array of size n minus 3. So it's kind of like induction, but not, or like going the other direction. And you can also build it out the other way with induction if you really like. But that's the kind of proof, is that if you do an exchange, you always lead to a suboptimal result because the optimal result now leads to is built on to be true for future optimal results, and that's part of the greedy / exchange argument type thing. I think that's all I have for this one. Let me know what you think. I think this is I think intuitively, I think a lot of people will get this one. It's not that bad per se, but I think the hard part is going to be the greedy proof and understanding it and how to get from it. And not even just that, right? You're probably asking like, okay, I get this, but what about harder problems, right? I think that's where, understanding the exchange argument and greedy solutions and stuff like that will help. So hope that kind of, set you on a good path. But yeah, that's what I have for this one. Let me know what you think. I didn't go over complexity. I mean, this is linear space and log n time, right? Yeah, it's very short code. That's what I have. See you later. Stay good. Stay healthy to good mental health. I'll see you later and take care. Bye-bye.